Hi, so today I'm gonna teach you how to use tree diagram to organize data and also to be able to find out different outcomes in a sample space. So I have just remind you that it's important that you watch the basic concepts of probability before watching this. Alright, so to understand basic terms. Now let's go to the following questions. How do we construct a tree diagram? How do we make a sample space from a tree diagram? So a tree diagram can be drawn either vertically. So there's like, this is the main data you're trying to show. And then the first set of outcomes out of a certain event. Then the next possible outcomes, if there are. Okay, so this is vertically made. And then the ones on the bottom are your number of possible outcomes, also your possible outcomes. Also, a tree diagram can be drawn horizontally. Okay, so this is your main event, the outcomes, and the next coming outcomes from a certain event you have made. Okay, so these are the two possible ways, vertically or horizontally. Now let's make a sample of a tree diagram. So for example, I am going to find out what are the possible outcomes of tossing a coin. So a coin and a dice together. Okay, so I want to identify what will be the outcome of tossing a coin and a dice together. Okay, so these are the things you need to take note. You start with your coin. Okay, this is only one event, right? We're trying to do them together. Okay, so this is what you do. You start with your main event. Okay, so tossing a coin. So toss a coin. So if you toss a coin, you either get a head or a tail. Okay? And remember, after tossing a coin, because we only said we toss it once, so it also depends on the data. If the data says you're gonna toss it twice, that's another story, and that's another tree diagram. So we only toss the coin once, so the possible results are head or tail. And then let's go to the dice. Dice has six possible outcomes. It's 1, 2, 3, 4, 5, and 6. Okay, so what you do, you have to add up 6 branches. Okay, 6 branches for your here. So we have 1, 2, 3, 4, 5, and 6. So this tree diagram is drawn vertically. We have 1, 2, 3, 4, 5, and 6. So now the question is, how do we make the sample space? Okay, so the sample space is the set of all possible outcomes. So we're gonna make it in a set notation. So when you talk about set notation, all the entire data are enclosed by braces. So we have here the first possible outcome will be this one. So the first possible outcome is head and then 1. So we're gonna use H for head and T for tail. Okay, so the first outcome is H1. So by that, you would also understand that the next possible outcome is head 2, head 3, and so on and so forth for the heads. So we have head 3, head 4, head 5, and head 6. Okay, so you need to understand these concepts. So the possible outcomes of tossing a coin and a dice could be head 1, 2, 3, head 2, head 3, head 4, head 5, and head 6. And let's go to the tail. So tail 1, tail 1, tail 2, tail 3, tail 4, tail 5, and tail 6. Okay, so this is how we formulate a tree diagram and how we make a sample space out of a tree diagram. Now let's understand some concepts regarding tree diagram, how to use it. So we have here tree diagrams can be used to illustrate sample spaces provided that the alternatives are not too numerous, so not too many. It should not be a lot so that it won't look like not anymore branches but already roots. Okay? So when there's a lot of outcomes possible, you will be using basic counting principles or other concept regarding probability. Let's go here. So here we have an example. The tree diagram can be used for determining probabilities. Consider example 5 again. The tree diagram for this information. So we have here F was able to catch a fish, and then N is not able to catch a fish. So this is the data given. So as you can see, we have made a tree diagram with the probability. Okay, so the probability shown here is for the first data. This is for Carl's result. Okay, so Carl's result is for catching a fish. Okay, there is a possible probability of 9 out of 10. So he has higher probability, and then not catching a fish is 1/10. Okay, while Dagma's result, because he's the second one to do it, was able to catch a fish is 4/5, and then not able to catch a fish is 1/5. And there's two sets of data for that. So therefore, you see more probabilities here. We multiply the data. So 9/10 times 4/5. So if both of them were able to catch a fish, this is the branch being described for this solution. Okay, so the probability for that is 36 out of 56. So both of them, Carl and Dagma, being able to catch a fish is 36 out of 50. But if Carl only will get a fish, will be able to catch a fish, and Dagma will not, this is the probability. Okay? 9 out of 50. So this is Carl catch a fish, Dagma will not. And then Carl not able to catch a fish, so N. And then Dagma was able to catch a fish is 4 out of 5. And then let's go here to the last one. Now we have the last result is this one, NN. Both of them not catching a fish is 1 out of 50. A very thin probability for not catching. Okay, so we have here, these are the observations. The probabilities for catching and not catching fish are marked in the branches. So this one, the branches. There are 4 alternative paths. Okay, 4 alternative paths. And those are the possible outcomes. Both of them catching a fish. Carl catching a fish and Dagma's not. Carl not catching a fish and Dagma was able to catch, or both of them not able to catch a fish. All outcomes are represented and the probabilities are obtained by multiplying the probabilities along each branch. Okay, so it's a one direction. You cannot divert to another direction. The probability of an event containing 2 or more outcomes is obtained by adding the probabilities of each outcome. So if you want to find out what's the probability of them being able to catch or Carl being able to catch, we just simply add them. Okay? So let's go to more examples here. During the summer holidays, the probability that Hiroko plays tennis on any day is 5 out of 7, and the probability that she swims on one day is 3 out of 50. 3 out of 5. So this is how we make a tree diagram. Okay, so there's 2 events happening. So tennis and swimming. Okay? So when you see this symbol, there is a symbol being shown. Okay, this one. That means not being able to play tennis. Okay? So draw a tree diagram. So let T represent the event Hikaru plays tennis. And S represent the event Hiroko swims. Okay? So here we have 5 out of 7 that she was able to play tennis. So that's 5 out of 7. So not being able to play tennis, this one is not being able to play tennis is 2 out of 7. To make a complete 7 out of 7 or 1 probability. Then swimming, you first make for the other one. So 3 out of 5 already and 2/5 because it's in the given. Okay, 3 out of 5. So to complete the data, it's 2/5 for not being able to swim. And the other also for the not going to tennis. Okay, so this is what you do. So these are the possible outcomes that you have. T and S, so being able to play tennis and swim. So the probability is 15 out of 35. Being able to play tennis at not swimming is 10 out of 35. Not playing tennis and swimming but being able to swim is 6 out of 35. Not playing tennis and not swimming is 4 out of 35. Okay, so you just have to multiply the data here that you have. 5 out of 7 is for T and then 3/5 is for S. Okay, and so on and so forth. So letter B, use the tree diagram to determine the chance that on any day Hiroko plays tennis and swims. So plays tennis is 5 out of 7 times 3/5. Okay, and swims. So that's 3/5. So the answer would be 15 out of 45. No, 15 out of 35, and then you can simplify that, divide by 5, and that would be 3/7. Or what you could do is directly cancel the 5, and it will be 3 out of 7. Or else, if you want to find out being able to swim but not playing tennis, so just look back to the numbers here and multiply them, and that would be the answer. Okay, so that's how we use the tree diagram.